Good morning, children. This is Aisha, and I'm here with today's topic for learning, that is the first chapter of chemistry, chemical reactions and equations. So, before we advance further, let us first recapitulate what we have learned in our lower classes about change. So, we have been learning about the various changes that occur in nature. You now know that everything tends to change, and change is the only constant thing in the universe. If you see around, there are many things that undergo change either temporarily or permanently, like the blooming of the flowers, formation of curd, change of seasons, water cycle, germination of seed, etc. So, some of these changes are temporary and some are permanent. So, based on this criteria, the change is majorly classified into physical change and chemical change. So, as you know, physical changes are those changes which bring about a change in the physical properties of a substance. Now, what are the physical properties of a substance? To list, their state, color, volume, size, shape. So if there is a change occurring in any of these properties, one or more properties, then such a change is called as a physical change. And what are the other properties of physical change? These changes are reversible. They can be reversed by some physical methods like magnetism, filtration, centrifugation, distillation, or evaporation. So we can bring back the original substance by simple physical methods. And it's also temporary. It's temporary change. Coming to the chemical change, if there is a change in the chemical composition of a substance, then such a change is said to be a chemical change. So, here, as a new substance is formed, because there is a change in the chemical composition, a new substance is formed with different set of physical properties also. So here we can say that it is a change which brings about a change in not only the chemical composition of a substance, but also brings about a change in the physical state or physical properties of a substance as a new substance is formed. Coming to the examples of physical change, you can take a simple example of melting of ice. Melting of ice, here ice changes to water, that is liquid, and it's solid. So what is changing here? This chemical composition remains the same. Ice is also H2O and the chemical composition of water is also H2O. But the difference is in the states. The solid state has got converted into a liquid state, and this can be reversed if you take out the cause for the change. So if you cool down, what will happen? If you freeze, the water will again change into a solid. So there is no way that the chemical composition is changed. If you look at another example of stretching of rubber band. What happens if you stretch a rubber band? The rubber band increases in its size. It stretches and its length increases. So which physical property is changed here? the size and the shape of the rubber band changes. So it's also, when you apply some force, it changes, and when you don't apply any force, when you remove the force, the rubber band again comes back to its original size and shape. Speaking about the examples of chemical change, burning of wood, and germination of seeds, etc., are the examples of chemical change. One good example is the burning of magnesium ribbon in air. So what is happening in all these examples? The original substance cannot be brought back by simple physical methods like magnetization or magnetism, filtration, centrifugation, or evaporation. It cannot be brought back. Once the wood is burnt, it's burnt forever. Once the seed is germinated, it cannot again become a seed. So once the magnesium ribbon is burnt, it is burnt forever, and it forms some new substances also. So let us see in detail the burning of magnesium ribbon. So what is happening in all these things? So in all these things, new substances are formed from a substance with different set of physical properties. If you take a look at this magnesium example, magnesium, when it burns in the presence of air, it burns with a flash of white light, and you can see after that there is some ash, grey colored powdery ash like substance produced, which has a different chemical composition. The original starting material was just magnesium. When it reacts with oxygen, it forms an entirely new substance with different physical properties. The product that is formed here, that is ash, magnesium oxide, has different chemical composition and different physical properties when compared to the starting material. So what is happening in this? The same is the case with the burning of the wood. New substances are formed when wood is burnt, like carbon dioxide and water vapor, along with liberation of a lot of energy. So here we need to learn about the definition of a chemical reaction. So you can see that it is a process in which one or more new substances are formed with different properties. So this change is nothing but called as a chemical reaction. And now, what is a chemical equation? So you can see that it is the symbolic representation of the chemical reaction that is actually taking place, wherein the reactant entities are given on the left hand side and the products are given on the right hand side of an arrow. So here reactants, one or more reactants, and towards the right hand side we write the products that are formed. So what is a chemical equation? For our convenience sake, it is the symbolic representation of a chemical reaction that is taking place, wherein the reactant entities are given on the left hand side and the products are written on the right hand side. Now, what are reactants? Reactants are those substances which take part in a chemical reaction. And what are products? These are formed in a chemical reactions. So products are nothing but the substances which are formed in a chemical reaction. So if we take an example of this magnesium, there are actually two types of chemical equations. One is word equation, where you can write the name of the reactants and products in words, or symbolic equation or symbolic representation, where you will be using the symbols and the formulae of various reactants and products, and you will be also mentioning under which condition these reactions are happening. So if you take the example of magnesium ribbon burning in air, I can write magnesium plus oxygen present in the air gives rise to, what is the product that is formed? It is magnesium oxide is formed. So it involves the using, this is word equations, so I'm just mentioning over here the words, the names of the reactants and products directly. So what is the other way of writing a chemical equation? It's by using symbols. Magnesium symbol is Mg and oxygen is always written as O2 because it is a diatomic molecule. So two atoms constitute one molecule of oxygen. So magnesium and oxygen gives rise to, what is happening over here? Magnesium oxide is formed. Now you need to also mention the physical state of these substances. So magnesium is a solid. For solid we write small s in brackets down like this, and oxygen is a gas, so we write like this, and the ash formed is also a solid as well, so we write S. For liquids we write small l, and for aqueous solutions we write AQ. What is an aqueous solution? It is a solution in which the solvent is water. So if it is mixed in water, we write it as aqueous solution. Hope you are following this, children. So what is a chemical equation? It is a symbolic representation of a chemical reaction that is happening by using various words or symbols and formulae of various reactants and the corresponding products that are formed. So the chemical equations that shows the chemical reaction needs to be balanced. And why is there a need to balance the chemical reaction? For this you need to know about one law, that is law of conservation of mass. Law of conservation of mass, which says that matter is neither created nor destroyed. What is this law? It states that matter is neither created nor destroyed. So, in other words, I can say that in a chemical reaction, atoms are neither created nor destroyed. So, a chemical equation must have equal number of each of atoms on both the sides. That means a chemical equation should have equal number of atoms of each element on both the sides of an arrow mark. That means on the left hand side, the number of atoms of each element should be same as that of the right hand side. To begin with, let us see first what are these. You can see a subscript over there. I have written O2. This is a subscript. What does it mean? It means that there are two atoms of oxygen. So it represents the number of atoms of this element. So if I write a number over here, like say for example 2H2, then this is the coefficient. This is called as the coefficient, which represents the number of molecules of this particular entity. So the subscript gives you the number of atoms and the coefficient gives you the number of molecules. Hope you know the difference between atoms and molecules. So atoms combine together to form a molecule. Here you can see two atoms of hydrogen are combining to form a single atom of hydrogen. Such two molecules of hydrogen are there. The coefficients should be written always in whole numbers. You can't write 1.1 or 1.5 or something like that. Usually it is written as whole numbers. You can write, if nothing is written, that means it is 1. You can add 2, 3, 4 in order to balance the number of atoms on both the sides. So here we come to another topic, subtopic of the lesson, which is balancing of chemical equations. Very important, children. You need to have a very good grip over the balancing of chemical equations. So as I told you, balancing is nothing but making the number of atoms of each element equal on both the sides. Let us start with a very simple equation. The same equation we shall take. Magnesium reacts with oxygen to form magnesium oxide. The first step is to write down the symbols of the chemical reaction, of the reactants and also the products. Now, so we'll see here different elements and how many atoms are there on left hand side and how many atoms of that element are there on the right hand side. So here you can see two elements, magnesium and oxygen. Let us write down the names, magnesium and oxygen. So magnesium on the LHS, this is LHS and this is RHS. How many atoms of magnesium can you see on the left hand side? Yes, it is 1. So atoms, nothing is written, no coefficient, nothing, no subscript. So it means it is 1 atom of magnesium on the left hand side. And on the right hand side also you see that there is 1 atom of magnesium. Now let us see oxygen. How many atoms do you see here? Subscript 2, that means 2 atoms of oxygen. No coefficient here, so only 2 atoms of oxygen on the left hand side, whereas on the right hand side there is only 1, no subscript, no coefficient, so there is only 1 atom of RHS, oxygen, in the RHS. So this is already balanced, we need not change it, but here we need to balance this, because one side there are 2 atoms of oxygen, another side there is only 1 atom of oxygen. For this we need to see, remember one thing, children, very importantly, you cannot change the subscripts. You cannot change the subscripts, but you can change the coefficient, because if you change the subscript, it would change the identity of the substance. See, if I change this subscript as O3, then what will happen? It changes into another substance which is ozone. So it is changing the identity of the substance. We need to change only the coefficients. That means we can put any number before the symbol, but we can't change the subscript. So now let us try keeping. I can't keep a number over here. So because it's together 1 molecule, so I can change the number of molecules by putting some number before it. So nothing is there 1, so I'll start with 2 MgO. Now let us see, again you need to check both, because now magnesium also became 2. So here it became 2 and oxygen became 2. Now the oxygen is balanced, but the magnesium is not balanced. In order to balance the magnesium on the left hand side, we can keep 2 over here such that now the number of atoms on the left hand side become 2. You can see that both LHS and RHS contain 2 atoms of magnesium and 2 atoms of oxygen. Hence, our equation is balanced. So, the final equation is 2Mg plus O2 gives rise to 2MgO. That is the balanced form of equation. I told you that you need to mention the physical state also. This is now the complete balanced equation. Let us try with another example. H2, that is hydrogen, reacts with oxygen to form water. Now, this is word equation. Let us change it into symbols. H2, because it is also a diatomic element, molecule. It's a diatomic molecule. That means 2 atoms of hydrogen constitute 1 molecule of hydrogen. Oxygen also. And what is the formula of water? It is H2O. Now what you need to do? The next step is elements, LHS and RHS. How many elements can you see in the reactant side? 2, that is hydrogen and oxygen. Hydrogen, how many atoms do you see on the left hand side? Left hand side you see 2 atoms of hydrogen. Yes, nothing is written over here, so only 2. And here also you see 2. Now here oxygen, coming to oxygen, again 2 atoms on the LHS, but here it is only 1 as no subscript is written over here. So O, nothing is there, so 1 atom of oxygen. We need to balance this. Now what can I do here? Can I write a 2 over here? No, that's wrong. We need to write, because it's one complete molecule, we need to write the coefficient before the formula, that is 2. Now it implies to the complete molecule. You can see that 2 you need to multiply with the whole formula. Now you see what changes now. Hydrogen 2 into 2. You have to multiply the subscript with the coefficient, because one molecule contains 2 atoms of hydrogen. 2 molecules contain 2 into 2, 4 molecules of hydrogen. So the number of atoms here become 4. Hydrogen atoms on the right hand side become 4 now, and oxygen, here subscript is 1. So 2 into 1, that is 2 atoms of oxygen. Here oxygen is balanced, whereas hydrogen is not balanced. As you can see on the LHS, there are only 2 atoms of hydrogen. So what can we do to make it? Can I make this as 4? No, I can't make this as 4, as I told you that it would change the substance completely. You can only change the coefficient. Here it is 1, now I can change it to 2. Now 2 into 2, it is 4. Is it balanced? So the balanced equation turns out to be 2H2 plus O2 gives rise to 2H2O. That's all for today, children, and I shall be taking up another class maybe tomorrow, where I'll be telling you some tricks regarding how to balance equations perfectly. Okay? Until then, practice and revise all that is taught today. Okay? Bye.